Hey everyone, now that you have an understanding of how we have integrated our experience and our unique technology approach to the SAT with all SAT prep questions and the integrated Desmos calculator, and we've showed you how you can use our platform to enhance your approach to everything overall, it's time to start with a few basics. What I've done is I've jumped into test number 2, module 1, and I've simply picked out 7 questions that I'm going to use to teach you some very basic features about the built-in calculator so that you can feel that you're creating a foundation to build upon, and we'll take it from there. To start, I have question number 3. Question number 3 is asking you to find the mean height of all of these heights in centimeters. And it's great to know that the integrated calculator, powered by Desmos, actually will calculate mean. Calculates more than mean, but it will calculate mean. And you'll see as I put the numbers in, it calculates the mean real time. So this is amazing because it's just knowing that it exists allows you to, boom, get the answer of 9. Now, if it asks for median, you could totally put median. It would arrange them from smallest to biggest, find the middle number, and if there's an even amount of numbers, find the average of the middle too. But the fact that it does it is awesome. And if you remember mean, median, and mode, but you don't remember the exact differences, it's so cool that the calculator is here and waiting for you. This next question offers us 2 really important things. The first is knowing that percent is something easily calculated by Desmos, but also there's a way in which Desmos will solve equations for you if your unknown is X or Y. So in this case, it says 13 is equals P% of 25. So I'm going to go 13, and then I'm going to say is, which is equals. Now I'm going to say, instead of P%, I'll say X%. When I put percent in, I'm going to do shift 5, and bang, it does percent, but it adds the of. And then I'm going to say 25. Now, what's amazing about this is that this calculator is so powerful that it will try to solve that equation, and boom, the answer is 52. That's wild all by itself. Just like that, I can click on the equation, get this gray dot, the x-intercept, or I can click next to the equation that I wrote, get the gray dot. Boom, that's awesome. Every once in a while, you don't get a gray dot. That's a unique situation. We'll explain that. But for right now, very cool. And of course, you could always zoom in. But the answer to this question is 52. Another way to take advantage of percent in this case is to go like this. I could say P% of 25 and make P a slider. And then I can change the values of P from 0 to 100. And for the moment, I'll make my step 1, meaning it's counting by ones. And I can actually watch it. And so the idea is I'm looking for 13 up here, but I want to figure out what percent of 25 is 13. 52% of 25 is 13. Very cool. I hope it totally makes sense and you feel awesome about it in every single way. I'm going to jump to number 8 here. And in number 8, what I really care about showing you is that I have this single equation. So in theory, just like we did earlier, you could take this single equation and you can put the entire thing in, and the calculator is so powerful that it's going to simply try to solve for the value of X. There are 2 values of X that make this equation work. One is -4, which makes both sides equal -36. The other is 2.25. Because I have no negative options, and neither one of these are 2.25, I can either look at these 2 and go, well, 4 goes into 9, 2, and a little more. 4 goes into 7, 1, and a little more. The answer is going to be B. Or if I want to, I can go like this and go 7 over 4, 9 over 4. Easy enough. Great to know you have a feature here where you can go back and forth between decimal and fraction. But either way, this is very cool. If on the off chance you put something in like this and you get no vertical lines, meaning that there is actually no solution, or you're having trouble seeing it because the gray dots don't appear, there is a pro move when it comes to a single equation. And the pro move is that you can go y equals the left side. And then you can go y equals the right side. Now, what this does for you is it allows you to see And look, you can make graphs appear and disappear as many times as you want, which is pretty cool. And in this case, I'm going to zoom in like this. It's allowing you to graph the left side and graph the right side and see where they cross each other to get the same exact solutions. This is cool because it's a very clear indication that using this Desmos calculator can actually aid in you having deeper conceptual understanding without stubbing your toes while you're doing calculations. And that's amazing all by itself as well. Finding a value of x that makes both sides equal each other means if I say y equals left side and y equals the right side, all I have to do is find the points where they cross, and those are the values of x that make both sides have the same y. And in this case, the y would have to be -36. But really cool. Also, a great feature is to notice how I have this quadratic, and this is a quadratic that's graphed here right now. But on your calculator in school, if you wanted to find the maximum point right here, or you wanted to find the zeros, you'd have to go to the calculate menu. And to do that, you'd say second, calculate, left bound, right bound. In this case, you can literally click on the maximum or click on the two zeros. It is pretty cool for a lot of different reasons. For the moment, I'm going to jump to a much harder question because this is what we should be doing. Like, let's show you how to do this. While the question itself is harder, it's really all about the features of Desmos. So you might not feel like you can do what I'm about to do on your own. Eventually, you absolutely will, but check it out. All I did was put in g of x equals 19 times a raised to the x. We don't know what a is, so I'm going to let a be a slider. That just means as a changes, the whole graph changes. In addition to that, I know I'm looking for g of 3, and that has to equal 2,375. So watch how cool this is. I can go g of 3, and automatically, it's so cool, but the calculator will actually solve this function when x is 3, which means it put 3 in here. And when a is 3.3, 3.3 raised to the third times 19 equals this. But I'm looking for 2,375. I can slide the slider and I can make it much bigger or smaller if I want to. But for the moment, I'm just going to go like this because I know that the answer happens to be 5 here, which is totally cool. All I did was slit it until g of 3 equals 2,375. Now that 5 is defined, this function is literally g of x equals 19 times 5 raised to the x. So because we're looking for g of 4, I'm just going to go ahead and say g of 4. Outrageous, crazy feature, super cool. The answer to this question is 11875. Unbelievable, worth sharing. Here we go. 3 more questions, just giving you a roadmap of features in Desmos that are unbelievable. Here we go. So this is an interesting question because there are no x's and y's. And because there are no x's and y's, there are several different things we can do. The first is the left side is p equals. So if I type in p equals, no matter what I put on the right side, it's going to ask me to make sliders for the things that are on the right, but it will solve for a value of the variable on the left. So let's say I make k 2.6 and I make j, I don't know, I'll go until this looks like a normal number on the right. How about I go like this? I'll make k a little bit. I'm just having a little fun here. But the idea still is I wanted to make something that was easy. All right, that's cool. J is 0.3, K is 10, and P is 0.98. I mean, weird, but at least it's just under 1, so I feel like I have a handle on what it's supposed to be. If I look at all the answer choices have to equal 4J plus 9. Because I've already defined J, K, and P, I can just go like this and go 4J plus 9. I know I'm looking for an answer that's 10.2. So what I'm going to do is I'm going to put in K over P, then KP, then K minus P, then P over K, and see which one gives me 10.2. We've created a relationship that has to be true up above. So when P equals 0.98 and K equals 10 and J equals 0.3, 4J plus 9 equals 10.2. And all of these values are the same values as K and P up top. So here I go, answer choice A, K divided by P. It is indeed 10.2. It looks like A is the answer. K times P. B is not the answer. K minus P. C is not the answer. I'm looking for 10.2. P divided by K. D is not the answer. The answer is A. That is a little bit next level, but hopefully you're like, all right, like I fully understand what happened. Whether you feel like you can do it on your own right this second isn't the most important thing. The most important thing is understanding that you can choose values for K and J. It'll find a value for P. And once they're all defined, you can put anything you want in and the calculator will do the calculations for you. That's the most important thing here. This is a 20 out of 22. And the reason that I put this up here is because I want you to see how seamless it is that you can use Desmos to not only graph any function you want, which we've already seen so far today, but in addition to doing that, you can use it to create all sorts of shifts and have a visual representation of the relationship. So here we have this graph. That's a graph of f of x. We're looking for g of x, and the value of x that makes g of x hit its minimum. Now we have the minimum of f of x, but we need g of x. You can literally type in g of x equals, and then you can define it as f of x plus 5. Now you may know that that's a shift to the left 5, but you may not. The fact that the critical values turn into gray dots, and we know when x is negative 13, y is 6. 6 is the minimum value, but negative 13 is the x value that gives us the minimum of g of x. Now, I'm shocked that 6 isn't a trap answer choice, especially for number 20, but here we have a simple approach to this, and hopefully it makes so much sense that you're like, all right, this is pretty cool. The goal is just choosing these questions. I'm choosing number 22, the last one, supposedly the hardest one. I'm choosing the questions to show you the Desmos features. This is a system of simultaneous equations. What I'm going to do is I'm going to put in both equations, because when you do that, you have the opportunity to see the two equations. I know that A is a slider, and you can see them as a graphical representation. Again, we know that if A was 1, the solutions are right here, 8.121 and 3.879. Those are the values of x that would make both y's equal the exact same thing, which is pretty cool. If you had 8.121, y over here would be 25.364, and y over here would be 25.364 when A is 1. Now, we're told that the graphs of the equations intersect at only 1 point. This is 2 points, so it can't be it. So what I'm going to do is I'm going to slide, and look, I'm going to click on the green line right now so I can see the 2 gray dots. So that way, as I slide this, I can actually watch those gray dots moving. I want them to come to 1 point because I want it to hit at only 1 point. That's my goal. I'm close. I don't know if -8 is it. We just changed my zoom here. It does look like it is. Look at that. Hold on. I was zoomed the right amount before. Close. There it is. It crosses and it hits 1 point. Sometimes you have to zoom a little bit different just so it does what you want it to do, just a nuance. But check it out. The point 6, 10 is the 1 point where these two cross when A is -8. Now it's the number 22 out of 22. So -8 here is a trap, a big trap. They are not looking for the value of A, which is -8. So I'm crossing this out. They're instead looking for the value of X, where they cross at that 1 point. So the answer is actually 6. Very cool and interesting. I really hope that this little tour, using only 7 questions, has given you a starting point to see that there's so many integrated and easy features in the Desmos calculator that can not only help your understanding of the math as a whole, but clearly make your entire experience doing SAT math much, much easier. Let's take it to the next level. Here we go.